Hello everyone. So in this video we will see the analysis of this circuit. We need to find VC1, VC2, IC1, IC2 and IR. Everything we will find. Okay. So all the concept that previously that we have studied, all those concepts will be used here. Okay. So just see the circuit carefully. So first thing you will see here is that there are two capacitors. So there are two capacitors. Two capacitors. So people may think it is a second order circuit. Right? Second order circuit, because I have told you what is the order of circuit, number of effective storing element. So is this the second order circuit? No, this is the first order circuit. Okay, because I have said effective storing element. Okay, effective storing element. So what will you do? Find effective storing element. Just short circuit the input. If I am short circuiting the input, what will happen? This R will come here. This R and C parallel combination will, one end will go to ground, right? This one end will go to ground and the other end will be connected to C2. Right? Now what do you see? These two comes in parallel. In parallel. So from here what do you see? Effective storing element is only one capacitor. Storing element is only one capacitor. Right? That is C1 plus C2, because both are in parallel. So what will be your time constant now? C, yeah. So here I will write C effective. So what is C effective? C effective is C1 plus C2. What is R equivalent? From here what do you see? What is R equivalent? R equivalent is R only. Right? So what will be the time constant? Time constant would be C1 plus C2. And from here you understand this is a first order circuit. So in first order circuit there will be only one time constant. If it was second order circuit, there would have been two time constants. Okay, so only one time constant is there, that is R into C1 plus C2. Okay, so first thing we need to find the order. Why we are finding the order? Because the solution that we have seen, y infinity plus y0 minus y infinity e to the power minus t upon tau, that is valid only for first order equation only. So only for first order circuit you can apply that equation. Okay. Also the exponential response will be there only for first order circuit only, not for second order. So only for first order it is valid. That's why it is necessary to find the order of the circuit. So first we found the order of the circuit, then we found the time constant. Now we will see what is happening in the circuit. So at t equals to 0, at circuit at t equals to 0. So tell me what is happening at t equals to 0. The capacitor will be shorted because both are having no initial voltage. So both of them will be shorted, and R in series, R in parallel. So R in parallel with some short. So equivalent will be short only, right? Like whatever there is connected, whatever resistance there is connected, and it is shorted. So the complete will be shorted only, right? R parallel with 0. So it will be R into 0 upon R plus 0. So it will be 0 only, right? So it will be shorted only. So what is happening at t equals to 0? That is 5 ut shorted and shorted. This will be shorted and this will be shorted. The complete circuit is shorted. So now tell me, what is the value of current? The value of current is 5 by 0. That means infinite current. And if there is infinite current, voltage, capacitor voltage will change immediately. Capacitor voltage will change immediately, right? right? Because of the infinite current, right? Now, how will you divide the voltage now? Okay, this we are only talking about at t equals to 0, not the complete circuit. Now, how will you divide the voltage at t equals to 0? In the previous question that we took, in this question, we divided in the inverse proportion because only capacitor were there, right? Now, what is happening? Here, we are having capacitor along with the resistor. So, now we can't divide in inverse proportion, right? Because the circuit is having a resistor as well. So, how will we divide? Now, for step input, at t equals to 0, omega is infinity. That means ZC 1 by j omega c, that will be very low. So what does that mean? Your R and C will be replaced with a single capacitor only, right? I have explained this concept in the previous video, right? Because at t equals to 0, very high frequency, because of very high frequency, it is providing very less impedance, and because of very less impedance, this will be replaced with a single capacitor only. So this configuration will be replaced with C1 only, right? So this will be replaced with C1 only, and going ahead, this will be replaced with C2, because there is no parallel anything connected, so this will be only C2. This is acting at t equals to 0 only, at t equals to 0 only. This all is happening at t equals to 0, and here I am having 5 volt at t equals to 0. Okay, and this is your forget about it, this is your circuit, right? This is 5 volt I can write at, because at t equals to 0. So this is your VC1 and this is your VC2. Okay, so although your VC1 for t equals to 0 minus was 0 volt, your VC2 for t equals to 0 minus was 0 volt, but your VC1 for t equals to 0 plus will be what? Tell me. It will be 5 into C1 upon C1 plus C2, and your VC2 at t equals to 0 plus would be 5 into C2 upon C1 plus, sorry, VC1 would be 5 into C2 upon C1 plus C2. And what will be VC2? It would be 5 into C1 upon C1 plus C2, because in case of capacitor, we divide in inverse proportion, right? We divided the voltage in inverse proportion. So this is the value of VC1 at t equals to 0 plus and VC2 at t equals to 0 plus. Because of the infinite current, it is changing its voltage immediately. Okay, and tell me what will happen at t equals to infinity. At t equals to infinity, what will happen at t equals to infinity? The capacitor will act as a open circuit. Capacitor acts as open circuit. Okay, so this is okay. I can write it as 5 because I am just talking about a particular time at t equals to infinity, and this will be open circuited, and this will also be open circuited. Okay, this capacitor is open circuited. This is a resistor R. This would be VC1. This would be VC2. Okay, so tell me what will be the VC1 value at t equals to infinity? Since there will be no current, because this is open circuited, so there will be no current here. So value of VC1 would be 0 volt only, right? The current, this current would be 0 ampere. Here the current would be 0 ampere. So your VC1 would be 0 and VC2 at infinity would be 5 volt, right? Did you get this point? And here, why didn't we apply that concept at t equals to infinity? We will have omega equals to 0, and what will be the impedance provided? Why didn't we apply this concept? Because there is no ambiguity, right? At t equals to infinity, if I draw the circuit, it is very simple circuit. I can tell you what is the value of VC1, what is the value of VC2, right? At t equals to 0, what was happening? There was ambiguity because it was shorted, and if the complete circuit was shorted, I couldn't tell what will be the value of VC1 and VC2. So because there was ambiguity, I had to make the circuit like this so that I can comment on VC1 and VC2, right? Because here this is saying 0 voltage and this potential is saying 5 voltage. This is saying here 5 will come, this is saying here 0 will come. So there was ambiguity. So because of that, I had to make the circuit like this. But here in this circuit, this circuit, there is no ambiguity. KCL, KVL, all are fine. Zero current, VC1 is 0, VC2 is 5 volt. Everything is fine. So I don't need to apply that concept. You can apply that concept, same answer will come. But I don't need to apply it. Okay. So basically, you know two things here. VC1 at t equals to 0 plus is 5 C2 upon C1 plus C2, or you can write it 2.5 volt, taking C1 equals to C2. Okay, for simplicity, I am taking C1 equals to C2 equals to C. And what is the value of VC infinity? That would be VC1 infinity, that would be 0 volt. Okay, so what do you think? What will be the equation of VCT? VC1T, that would be 5 C2 upon C1 plus C2 into e to the power minus t upon tau into ut, and that is equals to 2.5 e to the power minus t upon tau ut, right? So this is the final expression. And what is the value of tau? Tau is the time constant, and that is equals to r into C1 plus C2, because C1 C2 both are in parallel, so this is the time constant. So this is the complete analysis for VC1. Okay, this is for VC1. Okay, now talking about VC2. So what was VC2 at t equals to 0 plus? That was 5 C1 upon C1 plus C2, or we can write 2.5 volt, right? And what will be VC at infinity? That will be 5 volt. So from 2.5 to 5 it is rising. So how will you write the expression of VC2t? That will be 5 volt plus value at t equals to 0 minus value at infinity e to the power minus t upon tau. So it would be 5 minus 2.5 e to the power minus t upon tau. So that would be your VC2t. Okay. Okay, so that would be your VC2t into ut. Okay, so and here tau is r into C1 plus C2. Okay, so I guess now you can make the graphs of VC1 and VC2. I know there are some things left, IC1, IC2 and IR, that we will see. Okay, so let's make the graph first. VC1 versus T. So what is happening in case of VC1? First 2.5 and then going down to 0, right? So we will make the graph like this. Initially it was 0, right? Then suddenly it went up to, because VC0 minus was 0. Then suddenly it went up to 2.5 and then goes down to 0, right? Then it went up to 2.5, then goes down to 0. So this is 2.5 volt and then it goes down to 0. Right? The time constant is R into C1 plus C2. This is going to be your VC2. So tell me what is happening in case of VC2. Initially 0, VC0 minus was, VC1 0 minus was 0, then it goes to 2.5, then rises to 5 volt, right? So here it was 0, here it was 0, then rises to 2.5, right? Then rises to 2.5 and then further rises to 5 volt, right? And what is the time constant? That is R into C1 plus C2. So that's the complete analysis for VC1 and VC2. Now you yourself will solve by Laplace transform. Just convert the circuit in Laplace domain. What will you do? This will be replaced with 5 by S. This will be replaced with a single resistor. This will be replaced with 1 upon C1S. This will be replaced with 1 upon C2S. So complete circuit will be replaced, and then you need to find the value of VC2 and VC1 using simple mathematics. That's it. Okay. So I will not tell that because Laplace transform is not useful here. Okay. We can solve in time domain only, but for your practice you can solve in Laplace domain as well. Okay. So this is all about VC1 and VC2. Now let's comment on IR. Now tell me what will be IR? IR will be the voltage across the resistor divided by the resistance value. That means VR by R. Now tell me what is VR? VR is VC1 only. Right? Voltage across the resistor is equals to VC1 only. No? This VC1 will be going there. Right? Do you understand? So what will be your IR? So now commenting on IR. So IR will be simply voltage across resistor divided by resistance R. What is the voltage across resistor? That is VC1 by R. Now just write down the equation of VC1 and just divide it with the R. So our answer would be 2.5 by R e to the power minus T upon tau ut. So that will be the expression of IR. Right? That will be the final expression of IR. Right? With tau being R into C1 plus C2. Right? So the same graph will be there. For if I need to make the graph of IR, this same graph will be there. Right? I am making the graph of IR. Just remove this. So just IR, the value will be 2.5 by R. Okay. So initially there is 2.5 by R current, and then this goes down to 0. Okay. Now commenting on IC1 and IC2. IC1 and IC2. Okay. So what will be the expression of IC1? Tell me. So you can see the VC1 waveform, right? VC1 waveform from 0 to some value, then decays down. What is IC1? IC1 is the capacitance value into the differentiation of this. Capacitance value into the differentiation of this. Now at t equals to 0, what do you see? From 0 to sudden jump. That means there will be impulse. Then there is graph like this. That means negative slope. So the current value will be negative. Are you getting this point? I am talking about IC1. In IC1, from 0 to sudden jump, that means there will be an impulse. Then what happens? Voltage graph goes like this. That means the slope is negative. That means the current will be negative. So current will go from some value to like this. Are you getting this point? Initially the current will be impulsive, then it will decay down to 0. Here you can see in this graph, what do you see? IC. Okay, let's just comment on IC values as well. So this was, sorry, not this. So this was your IC2 and this was your IC1, right? So your IC1 at infinity is equals to IC2 at infinity, that is equals to 0 ampere, right? Because this is what steady state is. Because at steady state, the capacitor current will be 0 only. And also in the circuit you can see open circuit, so current is 0. So steady state the current should go to 0, and that will happen here. At steady state the current will go to 0. But the thing is, at t equals to 0 plus, what will be the value? At t equals to 0, what will be the value of current? Impulsive. At t equals to 0. Impulsive. What will be the value at t equals to 0 plus? From here, can you make the graph of IC1? Yeah, you can make without the values. Impulsive current will come because there is sudden jump. So impulsive current will come. And then at infinity it will go down to 0. And also you can see the slope is negative, so the value will be negative. So the graph will go something like this, exponentially decaying from some value to 0. Now what will be the value of this one? That is the task. And now just draw a dummy graph of IC2 as well. Draw a dummy graph of IC2. Just think about it. What will happen? Draw it on rough notebook, then only see it. Okay, then only see the final solution. Draw it in your rough notebook. What will happen? Sudden jump, impulse current. Okay, good, impulse current. Then the slope is positive, VC2, so slope is positive. So the value will be, so voltage value will be positive only. Now where it will be, we don't know. So let's just assume the value is here. So then voltage value will be positive and decay down to finally 0. So this will be the dummy graph, but we need to know the values. Okay, so how will we know the values? So simply by writing the expression. So what will be IC1T? That will be C1 dVC1T by dt. So C1, what is the value of dVC1? That is 2.5 e to the power minus t upon 2 ut. Okay. Now, oh, okay, sorry. Here I need to write d by dt. d by dt. C1 d by dt 2.5 e to the power minus t upon 2 ut. Now, many of the students will differentiate it something like this. What they will do, C1 ut will come ahead, so they will just differentiate this part. So it would be 2.5 by 2 and negative value e to the power minus t upon 2 and ut remains there. Now this is wrong. Okay. Only part that can come outside is 2.5 only. Okay. This is also a time domain function. This is also a time domain function. What I am saying, this is also a time domain function and this is also a time domain function. Both are time domain functions. Time domain functions. Both are time domain function. So you have to apply u into v. So how will you do? 2.5 C1 first as it is e to the power minus t upon 2 as it is. Differentiation of this. What is the differentiation of ut? That is delta t. Then this as it is, differentiation of this. What is the differentiation of this? It would be e to the power minus t upon 2 into ut as it is. Now tell me what will be the value of this? 2.5 C1. What will be the value of this? That would be delta t only. Right? Because I have told you e to the power minus, like anything, any function xt into, okay, I will write it clearly. Xt into delta t can be replaced with x0 delta t. How does that happen? I have already told, right? So xt into delta t is replaced with x of 0 into delta t. I will give you one more quick review. Let's just assume this is your xt. And what is delta t? This is delta t, right? This is delta t. Now you are multiplying both of them. Now what will happen? These values are 0. So all these value will go to 0. Only this value. Let's just assume xt is having a value at t equals to 0. Xt is having a value at t equals to 0. So this will be impulse into a. So this will be your answer, a into delta t. So xt is x of 0 is a. So basically your final answer is x of 0 into delta t. So this is what is happening. X of t into delta t is x of 0 into delta t. So what is x of 0? E to the power minus 0 upon 2. So it will be 1 only. So delta t only there will be. Okay. There will be only delta t minus e to the power minus t upon 2 ut. Okay. So let me write it on next page. IC1T. What is the value of 2? That is R into C1 plus C2, right, into UT, This is the final expression only, no? Yeah. So what do you understand now? Let's make the graph of IC1. In between we will make the graph IC1. So initially we have an impulse of the magnitude is not the magnitude, the area is 2 point like this. The area is 2.5 C1, and here then this is only at t equals to 0. Then we have an step function as well. So we have basically two functions. One is this and the other one is this. It will start from some negative value and eventually at t equals to infinity it will go down to 0. So just add them two. So we will end up with this graph. So it will start from some value that is 2.5 C1 upon R C1 plus C2. Okay. So it will start from 2.5 C1 upon R C1 plus C2 and it will decay down to 0. This is ICT graph. Okay. So are you guys able to understand just the voltage waveform and differentiation? And intuitively, if you need to think just the dummy graph, if you just don't need these values, if you just need a dummy graph, how will you think? You will see this is the voltage waveform. So first impulsive, then negative current, and current going to 0. Impulsive, negative current that is going to 0. Right? Because eventually the current is going to 0. Here, first in VC, in IC2, what do you see? First impulsive, then positive current that is going to 0. So positive current that is going to 0. Okay. So now we will comment on IC2. Okay. So IC2T now. So what will be IC2T? That would be C2 dVC2 by dt. Okay. So C2 into d by dt into what is VC2? VC2 is 5 into, okay, yeah, there is one error here. This complete function will be into UT, right? So this complete function will be into UT. Okay, this is an error. Okay, like first I wrote 2.5 into e to the power minus t upon tau into UT. So, but the complete function into UT. Okay, so it is 5 minus 2.5 e to the power minus t upon tau into UT, right? So what I can do? I can consider this as first function, or instead of that, what I will do, I will write d by dt 5 ut minus 2.5 e to the power minus t upon 2 ut. That's how I will write. Okay, I will add more pages. Okay, so that's how I will write. So IC2T, that will be IC2T will be differentiation of this 5 ut, that will be 5 delta t, C2 into 5 delta t. Okay, now I need to apply u into v for this one, right? So minus 2.5 u into v for this one. So first as it is e to the power minus t upon tau, differentiation of second, now differentiation of the second one, and first as it is. I solved it very quickly because we have already solved it. Okay, so it would be 5 C2 delta t minus 2.5, inside it will be only delta t minus e to the, okay, instead of that I should write, wait a second, I should write like this. 2.5 C2, this will go to delta T plus 2.5 C2, this 2.5 into C2, and this minus will go to plus e to the power minus T upon tau into tau ut, right? So finally my IC2T would be 2.5 C2 delta T plus 2.5 C2 upon R C1 plus C2 into e to the power minus T upon tau ut. So if you are differentiating, differentiate with complete concentration, okay? Otherwise you will get the wrong answer, okay? Because differentiation is different. You can't take ut outside, okay? So u into v you need to apply, okay? So let me make the waveforms. Waveform for IC2T, okay? IC2T will look something like this. So first an impulse, this shows the area, not the magnitude. 2.5 C2, that is the area, and now an response. So I think I should write it upward. I can write it here 2.5 C2, and then this value 2.5 C2 upon R C1 plus C2. Okay, forget it, I will write later on this value, and that is decaying down to 0. So this value and that is decaying down to 0, okay? So impulse and then a value that decays down to 0. Okay, and this value is 2.5 C2 upon R C1 plus C2, and this time constant being R into C1 plus C2. So this is the complete analysis of the circuit. Okay, first we saw the voltage waveforms. What did we do? Well, first we see that infinite current, that means there will be impulsive current. Because of impulsive current, we have to take at t equals to 0, we have to make the circuit like this. So VC 0 plus, VC2 0 plus. Then we go to know, then we show the circuit at infinity, then we go to know these values. Then we go to know the waveform of VC1, then we go to know the waveform of VC2. And because of the VC1, the same current voltage is going across the resistor, so we could write down the value of IR as well. Then we wrote down the value of IR. Then after that we need to comment on IC1 and IC2. Then we go to know IC1 and IC2 will look something like this, because IC1 is C1 into dC1 by dt and IC2 is C2 into dVC2 by dt, and that's the final waveform we get. Okay. One more thing I want to see, if I have in the previous example, in this example, not in this, sorry, not in this example, the very initial example that we took, very initial example, yeah, this one. So did I comment on the value of current? Yeah, I commented on the value of current here. Okay. So yeah, I just needed to check if I made this graph or not. So I made this graph. Okay. So now let's go to the circuit once again. Now, okay. So if they were asking what is the value of impulse current, so do you think you need to solve the equation? What will be the value of IC1 at t equals to 0? IC1 at t equals to 0. Do you need to solve this equation? No, you don't need to solve this equation. How? Look, you already know your voltage is going from 0 to 2.5. Your voltage is going from 0 to 2.5. What is the current? Current is IC1 would be C1 into dVC1 by dt. I am only talking about at t equals to 0. Okay. So C1 at t equals to 0, what is happening? The voltage is going from 0 to 2.5. So what will be dVC1? What will be dVC1? 2.5 minus 0, right? By delta t, time is 0 only. Delta t means impulse. So 2.5 into C1, 0, that will be replaced with delta t. Did you get my point? Look, if you are a gate aspirant and you don't understand these things, it is fine. You can solve by equations as well. But I am trying to tell all these things so that your brain develops. Okay, when you go to analog electronics with all these concepts, the analog electronics will be a cakewalk for you. Okay, understanding capacitor is very much important for analog electronics. Okay, so we are going very deep into the capacitor. There is no concept, a single concept will not be there that you don't know. Okay, so what I am doing, C1 into dVc1 by dt. So voltage is going from 0 to 2.5. So what will be the value of dVc1? dVc1 shows the change in Vc1. So the change in Vc1 is 2.5 minus 0. In what time? 0 time. So 2.5 into C1 and this 0 will be replaced with delta t. Like we were writing dq by dt, right? So what we were saying, I am giving I naught amount of flux, I naught amount of charge in 0 time. So what I was writing, I know delta t. So the value of current was I know delta t. So I naught in 0 time. So I was writing I naught into delta t. So here 2.5 into C1 in no time. So the current will be 2.5 into C1 delta t. Are you getting my point or not? You are getting my point, right? So I am giving 2.5 into C1 charge in no time. So my current would be 2.5 into C1 into delta t. Are you getting my point? Okay. And similarly here, similarly the current will be 2.5 C1 into delta t. Okay. Now what is the value of current at t equals to 0 plus? That is minus 2.5 C1 upon R C1 plus C2. This also you can tell intuitively, but this is out of the scope of GATE students. Okay, there will be much deeper analysis. So I am not putting that video here. Okay, I will make a separate video for placements, guys, those who are aiming for placements and studying this subject. So for them I will make a different video. Okay, this value also you can take right intuitively without writing the equations, but this is a very deep concept, so I will just make another video for that. Okay, so those GATE aspirant who needs to see the intuitive analysis of this thing as well, so they can watch that video. Okay, so in the next video only I will put a video there. I will tell the value of IC1 at t equals to 0 plus. That means this value, how we are getting this value. This value intuitively you have understood. Impulsive current, because of that 0 to some value, so impulsive current. So this value you have already understood, IC1. Now this value we will comment in the next video. If you don't even understand this value, equations are there. Very simple concept. By equations we can solve as well. Okay, no hurry. In equation we can simply solve and get to our final answer. Okay, but I just hope that you are also interested in developing your brain. If you are developing your brain, these concepts are very good. Okay, impulsive current, then going like this, then just differentiating and getting through the final answer. Okay, so I hope you understood the concept, and now you need to solve the circuit by Laplace transform on your own. Okay, I'm not going to solve Laplace transform here because the equations will be a lot of equations will be there. Okay, so let's just forget about the Laplace transform. Now let's move on to our next circuit, that is this circuit. Similar circuit to the previous analysis only, very similar. What is happening? This parallel RC combination was there and this was here. So now this capacitor is going here, this parallel combination coming here. Okay, so I guess you should solve the circuit on your own, then only you should watch the final solution. Okay, just solve the circuit on your own. First tell me what is the order of the circuit. Order, what is the order? Second order? Second order? No. Why so? Because let's see the circuit. Short circuit the input. Okay, short circuiting the input. This will be C1, this will be C2, this will be resistance R. So effective will be this, right? So what will be your time constant? Again the time constant is going to be R into C1 plus C2, right? Time constant is R into C1 plus C2. So it is first order, right? Now what is happening at t equals to 0? You can clearly see what is happening at t equals to 0. This capacitor will be shorted, this will be shorted. So there will be an impulsive current. This is 5 volt, this capacitor is shorted, this capacitor is shorted, right? There will be an impulsive current, right? Infinite current. So capacitor will change its capacitor voltage will change immediately. Will change immediately, right? So how will it change? At t equals to 0, this C1 will be C1, this will be replaced, the parallel combination of R into C2 will be replaced with C2 only, right? At t equals to 0, frequency constant is infinity. So what will be the circuit at t equals to 0? This 5 volt is there. This C1 comes here and this C2 remains as it is, right? This is VC1, this is VC2, right? So what will be the value of VC1 at t equals to 0 plus? A similar analysis, nothing different. This parallel combination of RC2 is replaced with the single capacitor. So what will be the value of VC1? That will be 5C2 upon C1 plus C2 into U, not UT. Here I will not write UT. Did I write UT there in the previous analysis? I hope I didn't write UT. Yeah, I didn't write UT because we are talking about a particular time at t equals to 0 only. So why should we write UT? We can write U of 0, that is 1 only. So just forget it. So VC2 at t equals to 0 plus, that would be 5 into C1 upon C1 plus C2. Right? So this will be the value of VC1 0 plus and VC2 0 plus. We will later on talk about the current. Okay. So, and what will be the circuit at t equals to infinity? Circuit at t equals to infinity. That will be this voltage 5 volt. Okay. This this capacitor will also be shorted. Sorry, open circuited, not shorted. This capacitor will also be open circuited, but the resistance will be there. This resistance will be there, right? This is your IR, this is your IC1, this is your IC2. All the currents are 0, right? IR at t equals to infinity, because this is open circuited, so no current is actually flowing. So IR, IC1 at t equals to infinity and IC2 at t equals to infinity. All the currents are 0 ampere. Okay. Now talk about VC1 and VC2. So no one will see the answer, everyone will write first. Okay. So tell me, what is the value of VC1 at t equals to infinity? Is it 5 volt or 0 volt? It's 5 volt, right? Because here we have 0, here we have 0, here we have 5 and no current here, so this will be 0. 5 minus 0, that means 5 volt. Okay. So VC1 at t equals to infinity is 5 volt. What is the value of VC2 at t equals to infinity? No current in this side, so VC2 at t equals to infinity is 0. Basically no current is flowing, so the same current, that is the same voltage that is there across this resistance R, the same voltage will be there VC2. So if current is 0, so VC2 is 0, and here 0 voltage, here 5 voltage, so VC1 is 5 volt. Understood? Simple concept. 0 voltage, 5 volt, so VC1 is 5 volt and VC2 infinity is 0 volt. Okay. So now you can comment on VC1 and VC2, right? So for VC1 at t equals to 0 plus is 5 into C2 upon C1 plus C2. 2.5 volt I can write, considering what? C1 equals to C2 equals to C, and Vc infinity is 5 volt itself. So what will be your, sorry, Vc1, so what will be your Vc1t? That will be 5 minus 2.5 e to the power minus t upon 2 ut. Okay, so that expression only I used. I just wrote down the equation directly. Okay, okay. And what about Vc2? Vc2 at t equals to 0 plus was 5 C1 upon C1 plus C2, that means 2.5 volt, and Vc2 infinity was, what was Vc2 infinity? That was 0 volt. So what will be the value of Vc2t? From 2.5 to it goes down to 0, t upon 2 ut. From 2.5 to it goes down to 0. Okay, so this is Vc1 and Vc2. So let's make the graph of Vc1. Okay, from 0 to it goes to 2.5, from 0 to it goes to 2.5, then it goes to 5 volt. 0 to it goes to 2.5, then it goes to 5 volt. Okay, what is the time constant? Similar time constant, R into C1 plus C2. Now what is the graph of Vc2? What will be the graph? From first 0, from 0 to it will go to 2.5, then it will decay down to 0 volt, right? From 0 to 2.5 it will go, and then will decay down to 0 volt. What is the time constant? Time constant is R into C1 plus C2. Are you getting this point or not? Okay, so this is Vc1 and Vc2. Now, do I again need to derive the IC1 and IC2? Because what is happening? Are you getting this point? In the previous analysis, what was Vc2 that is becoming Vc1, and what was Vc1 that is becoming Vc2, right? In the previous analysis, if you see, this was your Vc1, this was your Vc2, and we simply differentiated it to find the value of, values of IC1 and IC2. Let's talk about IR now. By the way, we can talk about IR now. What is IR? What is IR? IR is simply Vc2 by R, right? Vc2 by R. This is IR, Vc2 by R. So what is Vc2? 2.5 e to the power minus t upon 2. That is 2.5 by R e to the power minus t upon 2 ut. This is your IR, right? I can simply copy this graph, paste it here. Right? What will change? Just this is IR and this value will change. This is IR and this value will be 2.5 by R. Okay. Now what we need to comment on? We need to comment on IC1 and IC2. Now again I am not going to differentiate, right? Because we have already differentiated it. So IC1 would be C1 dVC1 by dt, right? So differentiation of this, what is the differentiation of this? It will be similar to what we get as this value. This will be your IC1 actually, right? So this complete value will be your IC1, right? So in the next page, I think I can write. So IC1 is C1 dVC1 by dt. Okay. So this will be your complete IC1. You can again differentiate because previously I have already differentiated. So I'm not going to differentiate it again. Right. So this will be your IC1. And here it will not be C2, it will be C1. Right. Wait. It will be C2 only. Wait. So what will be that value? So VC, we are talking about IC1. So 2.5 C1 into delta T. So that would be 2.5 C1 into delta T goes from 0 to 2.5, but for capacitor C1. So here it would be C1 only. Okay. Here would be C1. And what about this? This value? We would be differentiating which function? We would be differentiating this function. Right? We would be differentiating this function. So we will be writing C1 into dVC1 by dt. So here C1 will come. This will be C1. Right? So here C1 will come. Right? We are talking about IC1. Let me recheck. Yeah, it's correct only. So nothing, just the differentiation. Just get this VC1 value, this VC1 value, and differentiate it. You will get this expression only. Okay. And now what will be the value of IC2T? IC2, that would be C2 into dVC2T by dt. So what will be the value of IC2T? That will be what expression? IC1 was this. This will be this expression. I think we should box it as well. Okay. Now I will just copy this. So this is the expression of IC1T, but we have to just replace C1 with C2 because we are writing IC2T. 2.5 C2 and C2. So this is the expression of IC1 and IC2T. Okay, and we can copy the graphs as well. Why we should waste time? We can copy the graphs as well. Okay, I will just copy the graph. This is actually the graph of IC2T, right? This is the graph of IC2T. Firstly, an impulse. Firstly, an impulse of 2.5 C2. This is C2 and then decaying down to 0. This is the graph of IC2T. And then this graph is of IC1T, right? Just the scenarios are changed, nothing else has changed. Okay, this is the graph of IC2T. just this will be replaced with C1, this will be replaced with C1, and this will also be replaced with C1, right? This will be 1, this will be 1, this will be 1. This is the graph of IC1T, this is the graph of IC2T. Just simple differentiation, the same analysis that we did before, but here I am not differentiating again because we have already seen it. Okay. So what is actually happening? The voltage waveform we are already having, then we are simply differentiating. In case of IC1, first an impulse, then positive slope, so positive current. So impulse and then positive current, and then impulse and negative current in case of IC2, because here the voltage is getting decreased, so negative current is there. That means the current will be negative. Okay. So one interesting thing you can see here is that the capacitor which is connected in parallel to the resistor, that is going down to 0. The capacitor which is connected in parallel to the resistor, voltage across that is going down to 0. In case of this, VC2 is going down to 0. It is going down to 0 and it is going down to going up to 5. And in this case, C1 capacitor was connected in parallel to resistance R. So in this case, what was going down to 0? C1 was. So basically the resistance R is discharging the capacitor, and then this capacitor is getting charged. So this is what is happening in the circuit. Okay. Do you understand this point? Do you understand? Okay. So this is the complete analysis of the circuit. Everything that is required to know. Okay. So these two circuits we have seen. Now we can see one more circuit in the similar way. Okay. So I will just draw that circuit and then we will see the analysis. Okay. Okay. So let's see the circuit. R1C1 or R2C2, both parallel combination now. Okay. And now you need to comment on all the parameters like IR1, IC1, IC2, IR2, VC1, VC2. Okay. For these three cases, R1C1 greater than R2C2, R1C1 less than R2C2, R1C1 equals to, okay, R2C2. It should be R2C2. R2C2. So you need to comment for all the parameters. Okay. So first let's just forget about the conditions. First let's just tell me what is the order of the circuit. What is the order and what is the time constant? Okay. Short circuit the input. Short circuiting the input. R1C1 parallel combination of R1C1. One end will be connected to the ground and the other end will be connected to the parallel combination of R2C2. R1, C1, R2, C2. Right? So tell me what will be the R equivalent? Sorry, not C effective. What is C effective? This C1 and this C2 both are in parallel, right? So C effective is C1 plus C2. And what is R equivalent? C1, C2 will become 1. So R equivalent will be R1 parallel with R2. R1 parallel with R2. So I can write R1 R2 upon R1 plus R2. Did you understand it? This is your R1. This is your R2. And C1, C2 will become 1 only. Right? This is C1 plus C2. This is R1. This is R2. So from here you are checking R equivalent. Okay. So what is your tau now? Time constant. That is R1 R2 upon R1 plus R2 into C1 plus C2. So this is the time constant and it is first order circuit only, right? Because C effective is only one capacitor, so it is first order circuit only. Now we can make exponential graphs. Okay. So first see what is happening at t equals to, oh no, wait, I guess I put it on the wrong page. Okay, wait. Okay, so now let's talk about the circuit at t equals to 0. At t equals to 0. So what will be the circuit at t equals to 0? 5 ut. What will happen at t equals to 0? Both will be shorted. C1 C2 will be shorted. So complete circuit will be shorted. The complete circuit will be shorted. So what will be the value of current? Current will be 5 by 0. That means infinity. That means capacitor voltage will change immediately. Change immediately. And how will the circuit be replaced at t equals to 0? Simply by the capacitance values, right? So at t equals to 0, it will be replaced with the capacitance values. So this will be replaced with C1 and this will be replaced with C2, right? So you can write down the values of VC1 and VC2 at t equals to 0. VC1 at t equals to 0 plus would be 5 C2 upon C1 plus C2, and VC2 at t equals to 0 plus would be 5 C1 upon C1 plus C2. Okay. I think I should keep it in the box. Okay, the currents will be impulsive. And yeah, one more thing, what will be the value of IR1 at equals to 0 plus? Because resistance is a very high impedance with respect to the capacitance at t equals to 0. At t equals to 0, at t equals to 0, omega equals to infinity. That means capacitor is providing very low impedance, right? Or let's just forget it. Okay, just forget this point. We can write down the value of IR1 and IR2 in different manner as well. Okay, so no need to push it. We can write down the values of IR1 and IR2 in different manner. Okay, so this is VC1 at t equals to 0 plus and VC2 at t equals to 0 plus. Okay, and current we will later on write. Okay, now let's talk about at t equals to infinity. So what will happen at t equals to infinity? The capacitors will be open circuited, right? So let me make the circuit. At t equals to infinity, the capacitors will be open circuited. This is R1, this is R2. Basically this is VC1, this is VC2. So tell me, is there any ambiguity in the circuit at t equals to infinity? Is there ambiguity? No ambiguity. It's very simple circuit, simple resistor divider that is there. Okay, so VC1 at t equals to infinity is simply resistor divider, 5 into R1 upon R1 plus R2, and VC2 at t equals to infinity is 5 into R2 upon R1 plus R2, right? So these are the values, VC at t equals to 0 plus and VC at t equals to infinity. Now you can write down the equation on your own, right? You can write down the equation on your own, right? Now what I will do, I will just do one thing. This is my VC1 and this is VC2. I can write down, I can write this down, write this down as 5 upon R2 upon R1 plus R2, R1. 5 upon 1 plus R2 by R1, right? I am just getting this R1 downward. So 5 upon 1 plus R2 by R1, and for this what I can write, 5 upon 1 plus R1 by R2, right? Just divide R2 in numerator and denominator. In numerator if I divide R2, 5. If denominator I divide R1 plus R1 by R2 plus 1. So this is what I have written. So, and similarly here what I can write, 5 into 1 plus C2 by C1, and here 5 upon 1 plus 1 plus C1 by C2. This would be 5 upon 1 plus C1 by C2, and this would be 5 upon C2 by C1, right? So now considering case 1 where R1 C1 is greater than R2 C2, or what you can write, R1 by R2, greater, R1 by R2 is greater than C2 by C1. So what is the value at VC1 at t equals to 0 plus, that is 5 upon 1 plus VC1 is C1 by C2, 1 plus C1 by C2, and what is VC infinity, that is 5 upon 1 plus R2 by R1. Now see one thing, or what you can write, R2 by R1 is less than C1 by C2. So which is larger? C1 by C2 is larger. That means this value is larger. That means this value is low. So VC1 0 plus is lower than VC infinity. So VC infinity is the larger value. Are you getting this point? Did you understand this point or not? Which one is the larger value? R1 C1 greater than R2 C2, it is given. So from there you can write R2 by R1 is lesser than C1 by C2. So R2 by R1 is lesser than C1 by C2. So C1 by C2 is larger value. So 5 upon 1 plus C1 by C2. So if this is larger, the lower one is larger. That means the overall is low. So this VC1 0 plus is lower than VC infinity. So now I am not going to write the time domain equation. You can write it down on your own, right? The equation you can write down, right? VC infinity plus VC 0 minus VC infinity e to the power minus t upon tau. Okay, on the next page we will go and we will just write VCT. What will be the expression of VCT? That would be VC infinity plus VC0 minus VC0 plus, we can write VC infinity e to the power minus t upon tau, where tau being R1 R2 upon R1 plus R2 into C1 plus C2. Okay, so you can put these values, this value and this value. You can put these values and you can write down the equation. But I am not going to put the values. What I will do, I will just make the graphs. So I will make the graph of VC1. Okay, I will make the graph of VC2. VC1 and VC2. Okay, so okay, I did not comment about VC2. So let's just comment about VC2 now. So VC2 at t equals to 0 plus was what? So this was for VC1, and here only I can comment about VC2 only. Here only I will comment about VC2. No need to go to this page. Forget about it. So for first condition, R1 by R2, this condition I am talking about. So VC1 at t equals to 0 plus, not VC1, VC2. VC2 at t equals to 0 plus was 5 upon 1 plus C2 by C1. And what was VC2 at t equals to infinity? That was 5 upon 1 plus R1 by R2. So tell me, which value is larger? Look, R1 by R2 is greater than C2 by C1. this value is greater, then that means overall is lower. So that means Vc2 0 plus is greater than Vc2 infinity, right? So this is one, and Vc2 0 plus was greater than Vc2 infinity. Okay, so let's just make the graph. For Vc1, 0 value was lower and the final value was higher. So the graph will go something like this. So I guess I need to use a different pen. So first it will start from 0, then suddenly it rises to a value, and then suddenly it rises to a value, of this value, and then it goes up to this value. So rises to a value and then goes up, right? So what is this value? Vc0 plus, that is 5 upon 1 plus C1 by C2. This is 5 upon 1 plus C1 by C2. And what is this value? That is 5 upon 1 plus R2 by R1. R2 by R1. We are talking about the case R1 C1 is greater than R2 C2. We are talking about this case, right? And what happens in case of Vc2? 0 value is larger. So first it rises. So from here it goes, then it rises to some value, okay, then decays down, right? It rises to some value and then decays down. What was the value? Vc2 0 plus was 5 upon 1 plus C2 by C1. And this graph I made wrong. Actually it doesn't decay down to 0, right? It's not decaying down to 0. It's decaying down to some value, some finite value, right? So 5 into, so the value was 5 upon 1 plus C2 by C1. 5 upon 1 plus C2 by C1. Upon 1 plus C2 by C1, and this value 5 upon 1 plus R2 by R1. This value is 5 upon 1 plus R2 by R1. Okay. 1 plus R1 by R2 it is, yeah, R1 by R2. 5 upon R1 by R2 it is 5 upon 1 plus R1 by R2. This is for the first case, right? Now for the second case, you know what will happen. For the second case, when R2 C2 is, sorry, R1 C1 is greater than R2 C2. That means R1 by R2 is greater than C2 by C1, or R1 by R2 is greater than C2 by C1, or R2 by R1 is less than C1 by C2, right? Two conditions are there, right? Now what do you think what will happen? In case of Vc1, 0 plus would be lesser than, sorry, would be greater than Vc1 infinity, and Vc2 0 plus would be less than Vc2 infinity, because values are already there, these values are already there. You just need to check this condition, because R1 greater than R1 by R2 is greater, this value is greater, that means this overall value is lower, that means Vc2 infinity is low. अरे भाई R1 by, okay, wait. R1 by R2 is lesser. This is lesser. Yeah. So R1 by R2 is less. R1 by R2 is less. That means this overall value will be larger. So VC2 infinity will be larger. Now talking about VC1 infinity, R2 by R1 is high. R2 by R1 is high. So this overall value will be low. So VC1 is low. So VC1 is low. Array yaar, VC1 infinity is low. Yeah, VC1 infinity is low. Just putting down the values, nothing else. Okay, just put down the values that is there, and from there you will get the waveform. So now the waveforms will be something like this. This will be our VC1, this will be our VC2. Okay, so in case of VC1, what will happen? 0, then some value rises to some value, and then decays down to some another value. Decays down to some another value. Okay, so initially what was the voltage? VC1 0 plus was 5 C2 upon C1 plus C2. It was 5 C2 upon C1 plus C2. What was the value? 5 C2 upon C1 plus C2, and then it was VC1 infinity was 5 R1 upon R1 plus R2. It was 5 R1 upon R1 plus R2. Right? And what will happen in case of VC2? Initially 0, then goes up to some value, then to some other value it go. Right? Right? This VC2 0 plus was, what was the value at VC2 0 plus? VC2 5 C1 upon C1 plus C2. What is the value at infinity? That is 5 R2 upon R1 plus R2. Right? Are you getting this point? So we have commented about, and what is the time constant? That we already know. Time constant we already know. Okay. So now we have commented about VC1 and VC2 for two cases. Now there is this third case. In case of third, R1 C1 is equals to R2 C2. Right? So from here what you can see, R1 by R2 is equals to C2 by C1, and R2 by R1 is equals to C1 by C2. Right? Both are equal. So what do you see here? Here you will see that VC1 at 0 plus is equals to VC1 at infinity, and VC2 at 0 plus is equals to VC2 at infinity. So all values are equal. So actually what is happening? This is your circuit. I will just draw the circuit. So this is your circuit, right? So what is happening here is that the values are getting stabilized very quickly, right? So this is your, this I am talking about VC1, and this I am talking about VC2. So if you draw the graph, what do you see? Whatever the value is there initially, so initial it's 0, then initially some value, the same value we will be having at infinity. This is the 0 at infinity, same value, so straight line. it happens only in first order circuit. Okay, 0 infinity same value, so straight line. Right? Also by equation you can also see, what would you write? V infinity plus V0 minus V infinity e to the power minus t upon tau and ut for whole ut. Now these two are same, so this will go down to 0. So only V infinity ut is left, and that is equals to V0. So same values are there, right? So same value is there. Okay, and the value is, for this it is 5 C2 upon C1 plus C2 equals to 5 R1 upon R1 plus R2, and for this it is 5 C1 upon C1 plus C2 equals to 5 R2 upon R1 plus R2. Now one interesting question I want to ask, what is the time constant of for this case? For these two cases we know the time constant, that is R1 parallel with R2 into C1 plus C2. What is the time constant for these two cases? Everyone should answer, everyone should write it in your rough notebook, then I will tell the final answer. So what is the time constant? The time constant is 0, right? Time constant is 0. Why so? Because it is getting stabilized immediately from 0 to the value stabilized. So here only we are getting the final value, right? In this circuit, in some circuit here, where has it gone? This one. Here we saw that the time constant was 0. Here as well the time constant was 0 because there was no resistor involved. So time constant was 0 because it was getting stabilized immediately. So it is taking no time to stabilize. So time constant here was 0. So in the similar manner, here as well the time constant is 0. Okay. So time constant is 0 here. Okay. And in this case, IC1 and IC2 would be simply an impulse, right? So you can make the graph and everything. Okay. So now talking about IC1 and IC2. IC1 and IC2. No need to write the values, we will just make the graphs. Okay. So what will be IC1? That would be C1 dVC1 by dt. And what would be IC2? That would be C2 dVC2 by dt. Okay, all the currents we will talk about, not just IC1 and IC2. We will talk about IC1, IC2, IR1 and IR2. All the currents we will talk about. Okay. And what about IR1? What will be IR1? IR1 will be VC1 by R1. What about IR2? IR2 would be VC2 by R2. Right? Okay. Now for the first case, we will not write down the values. Okay, you can differentiate and write down the values. For the first case, R1 C1 greater than R2 C2. Okay, so I will draw the graph of IC1, then I will draw the graph of IC2, I will draw the graph of IR1, and I will draw the graph of IR2. All four graphs I will draw. Okay. Values we will not find. Okay. So first I am drawing the graph of IC1. So for the first case, R1 C1 greater than R2 C2. So this is the graph of VC1. So what is happening? The voltage VC1 is rising. That means slope is positive. So current will always going to be the positive one. Okay. So first we will have an impulse because of the infinite current. first we will have an impulse. First we will have an impulse. Okay, what will be the magnitude of the impulse? The change in the voltage, from 0 to some value, that is 5C2 into upon C1 plus C2 into change in voltage into the capacitance value, that is C1. So it would be 5C1 C2 upon C1 plus C2 delta T. What was the change in voltage? From 0 to 5 C1 plus C2. Now what is the current? That is C1 d Vc1 by dt. So this was the change into C1 delta T. That would be the current. So this is what I have written. Right? This is the current. Then the slope is positive. So it will decay down from this value to 0. Okay? From here to 0. Now let's comment on IC2. First we will have an impulse, right? The same impulse we will be having. This much impulse. So that will be 5 C1 C2 upon C1 plus C2. The same impulse we will be having, right? Because of the sudden change, we will be having an impulse. The value will be same because the change in Vc2 is 5 C1 upon C1 plus C2. So what will be the current? C2 into d Vc2 by dt. So this change is this into the capacitance delta T. So it will be 5 C1 C2 upon C1 plus C2, right? 5 C1 C2 upon C1 plus C2. Now here what do you see? In first case the slope is negative. Right? So it will start from here and will decay down to 0. Right? Right? Now the thing is you don't know this value. This you can find only by differentiating it. Okay? This value you can find only by differentiating it. Okay? No one will ask you this value in the gate exam or in the written exam. And if they ask you, then you can derive it. But in the interview they may ask you. So for that I will make a separate video. That's out of the scope of gate aspirants. But if you want to know, even if you are a gate aspirant and if you want to know how do we find intuitively this value, then you can watch that lecture. Okay, the lecture that I will make later on. Okay, so intuitively as well you can tell this value, but that is out of the scope of gate aspirant, so I am not telling. Okay, that will be much deeper concept, we will see that. Okay, but the whatever that I am telling, that is helpful for your written test and for gate exam. Okay, but for interview, intuitively you need to tell, so that we will see. So now IC1 IC2, now talking about IR1, and then we will talk about IR2. Okay, so talking about IR1, what will be IR1? It will be simply Vc1 by R1 and Vc2 by R1. So whatever this voltage is divided by R1, that would be Vc1. Okay, not this one, this one. And whatever this voltage is divided by R2, that would be Vc2. So do I need to make it? I don't think I need to make it. Okay, I will make it because it won't look good. If I don't make it, it won't look good. Okay, so IC1 is actually rising like this. Oh, no, not IR2 doesn't go like this. IR2 goes like this. not to 0 but to some particular value. Right? These values you can write on your own, right? Just the value of VC1 by R1, that would be this value, and these values you can write. Okay. Now let's take the second case, that is R1 C1 is less than R2 C2. Okay, so make the graph for them. So I will just pause it and make the graph, because you already know how will the graph look like. Let's just talk about, okay, let's just talk about IC1 and IC2 first. Okay, no need to pause it. Let's just talk about IC1 and IC2. IC1 T, IC2 T. Okay, so let's talk about IC1. For the second case, first it rises, impulse will be there. What will be the amount of impulse? C1 into the voltage change, right? The amount of impulse will be C1 into voltage change. What is the voltage change? That is 5C2 upon C1 plus C2. Voltage change is 5C2 upon C1 plus C2 into C1. So it would be 5C1 upon C1 plus C2. Then voltage decays down. That means current will be negative. So it will start from some negative value and keep on decaying down. Okay. And you can make it like this. Like how? Like this. Initially it was 0. Initially it was 0. Then it goes to some value and decays down like this. Then here initially it was 0. Initially it was 0. Then an impulse will be there. What will be the amount of impulse? The change in voltage. What was the change in voltage? The change in voltage. The change in voltage was 5 into sorry, here C1 C2. So what was the change in voltage? Change in voltage was 5 into C1 upon C1 plus C2. It was 5 into C1 upon C1 plus C2 into the capacitance value, that is C2. Okay. Then from some value it goes, and since the voltage is getting up, that means if voltage is getting up, that means what is happening? Voltage is getting up, that means the current is positive. But current is positive and decays down to 0. Current positive, that decays down to 0. At steady state, the capacitor current will always be 0. I can't comment about the resistance current. Resistor current I can't comment, but capacitor current will always be 0 at steady state. Right? We don't know about the resistor current, but capacitor current will always be 0 at steady state. Okay. So this is the second IC1 and IC2. Then you can draw the graphs of these IR1 and IR2. So these will be similar only, actually. Just the graphs will be interchanged. This will be the graph of IR2, right? And this will be the graph of IR1. And this will be the graph of IR2. Okay. Now for the third case, R1 C1 equals to R2 C2. So tell me, what will be your IC1 for the third case? What will be your IC1 for the third case? And what will be your IC2? IC1 and IC2. Only an impulse will be there, right? This is the third case. Only an impulse will be there, because differentiation of this will be 0 only. This is a step function, right? VC1 is a step. VC1 is a step. What is the differentiation of step? That will be impulse. Or you can see at t equals to 0, we have a sudden jump, then we have constant. So if Vc is constant, that means current will be 0. So only an impulse current will be there, and that has the magnitude of 5C1 upon C1 plus C2. 5C1 C2 upon C1 plus C2. 5C1 C2 upon C1 plus C2. Five C1 C2 upon C1 plus C2, and here as well 5 C1 C2 upon C1 plus C2. Okay, and for making the graph of IR1 and IR2, simply these values will be there. Simply these graph will be there, nothing different, because just we have to divide the values by R, right? I hope I am able to copy it. Yes. IR1 and IR2. So what is the value of IR1? Simply the voltage. What was the voltage? That was 5. What was VR1? Sorry, VC1. What was VC1? That was 5C2 upon C1 plus C2 by R1, right? And what is the value of IR2? That would be 5C1 upon C1 plus C2 by R2. These are the graphs. Okay. Okay. So these are the final graphs. Are you getting this point? You can write down the values because it will be very big values. So I am not writing down the values. I am just making the graphs. So main target here would be the graphs. Okay. So I hope you have understood all the concept that I am trying to give. Now there will be more concepts. Okay. So we will see them one by one. Okay. Just keep on watching the videos. You are understanding everything. Just write it something in your rough, whatever I am doing, and then you are having a brilliant clear notes and everything. Okay. So if you like the videos, please do share it with your friends. So later on we will see more circuits and more analysis. Then we will see a lot of examples and everything will be clear to you. Okay. So let's meet in the next video. Okay. Thank you.